Today we are going to learn confusion matrix and other performance matrix in a way that's not so confusing. So suppose you're working on a machine learning model that predicts whether a person will have a health condition based on their lifestyle choices like sleep quality, water intake, and junk food consumption. You train the model using the training data. Now that we have trained our machine learning model, the big question is, how well does it work on new, unseen data? After all, without testing, how would we know if the model actually works? So, for example, we take these 20 unseen data points for testing, run them through our model. We take the predictions and classify the predictions based on whether the model was correct or not. So, here's how the classification looks like. The model correctly identified 6 people who actually do have health conditions. It got these predictions right. The model also correctly identified 8 people who do not have health conditions. These are called true positives and true negatives because they are the correct predictions. Then the model made a mistake. It said 4 people have health conditions when in reality they don't. These are false alarms. The model missed the mark again by predicting that 2 people do not have health conditions, but they actually do. These are called false positives and false negatives because they are the wrong predictions. So, using this data, we can create a matrix of actual behavior against predicted behavior. This table or matrix that we created for the predictions made by the model is called a confusion matrix. This particular one is a 2 cross 2 confusion matrix because we have only 2 classes. And a confusion matrix is a table that shows how well a classification model's predictions match the actual outcomes. From this confusion matrix, we can calculate a bunch of numbers related to the performance of the model. First is accuracy. It tells you the proportion of correctly predicted cases out of the total cases. The formula for accuracy is correct predictions, that is true positive plus true negative, divided by the total predictions made. So for our example, correct predictions here are represented in green and the total cases is 20. So accuracy would be 6 plus 8 divided by 20, which is 0.7 or 70%. The model correctly predicts 70% of the cases. Precision answers the question of all the cases the model predicted as positive, how many were actually positive? It's calculated by dividing true positives by total number of positive predictions. That is, true positives plus false positives. A high precision means fewer false positives. So for our example, precision would be 6 divided by 10, which is 0.6 or 60%. So out of all people predicted to have health conditions, 60% actually do have health issues. Then we have recall. Recall answers the question of all the actual positive cases, how many did the model correctly identify? It's calculated by dividing true positives by the total actual positives. That is, true positives plus false negatives. A high recall means fewer false negatives. This is different than precision because here we are concerned about total actual positives and not the predicted positives. So for our example, recall would be 0.75 or 75%. So the model catches 75% of the people who truly have health conditions. So precision and recall are opposites. Precision focuses on reducing false positives, and recall focuses on reducing false negatives. We sometimes need a matrix that balances both, and for those scenarios, we have F1 score. F1 score is the harmonic mean of precision and recall, giving you a single metric that balances both precision and recall. So the harmonic mean will look like this. And it can be simplified into this equation by basic mathematics. So back to our example, the F1 score would be 0.67 or 67% by putting in the numbers. The confusion matrix and related matrix give you a deeper understanding of your model's performance beyond just accuracy. They help you see where your model is getting things right and where it's making mistakes, which is crucial for making improvements. This is all for this video. Thanks and see you in the next one. Bye bye.